All right, writing equations of parallel and perpendicular lines. Somebody explain to me what converse of a conditional statement is.
Interchanges in the hypothesis and conclusion.
So basically they take the sentence and they take the first half and they flip it with the second half. What is one thing you need to know about the converse of the conditional statement, though? It may or may not be what? True. Yeah. Just when you flip the hypothesis and the statement, doesn't necessarily mean that the converse is a true answer. So you do have to check whether it's true or false. So we learned that if two non-vertical lines have the same slope, they are parallel. The converse of that particular statement is also true. If two lines are parallel, then they have the same slope. This is going to lead you into understanding parallel lines. I just kind of read through here. If two non-vertical lines in the same plane have the same slope, then they are parallel, and then the converse of that, which is what I read, is also true. So let's look at example 1. Put this in your journals. We're going to write an equation that passes through the point -3, -5, and is parallel to the line y equals 3x minus 1. So when you have two lines that are parallel, what is the only information I need out of this whole equation? I only need one thing out of that equation. What do I need? Parallel lines, what do we know about them? They are parallel, meaning they have what?
Same slope.
Same slope. We just read it, guys. So the only thing I need out of this second equation is the slope. After that, I'm going to use this point to find the new y-intercept, because I'm going to plug the 3 where the x is, and I'm going to plug the -5 where the y is. So I'm going to say -5 equals 3 times -3 plus b. So we can find our new y-intercept. So what's 3 times -3? How do I move the 9? Plus 9. What's -5 plus 9? +4. So my new y-intercept is +4. What they are asking is that the equation of the new line. So I start over again and I say y equals, they have the same slope because they're parallel, and then I just put my new y-intercept. Okay, you have done this before. It's been a couple lessons, I think. So remember, when they say write a new equation parallel to this one, all you need out of that is the slope. Because you see how the new y-intercept, if I were to graph these two, this one would be at +4, so it'd be something about going here. This is at -1, so it'd be somewhere right in here, but they would be parallel lines. Okay? All right, look at perpendicular lines. And I have gone over these, but I do also teach this same information to the 8th graders, so I sometimes forget who I've told what. So if you guys haven't heard it before, just let me know. All right, perpendicular lines intersect and they form a right angle, remember? So look at this example. They have two lines that intersect, and you can see right here, I should do it in red because that's what perpendicular lines usually are. This little box here means that they form a 90-degree angle. That's what perpendicular means. You guys remember that, correct? Forms a right angle. When you compare the slopes are the opposite inverse. Opposite inverse. So you see how this slope was -3/2? Opposite means the sign changes. So the new sign would be positive. Inverse means you flip the ratio. You flip the fraction. Opposite inverse, yep, going again. So we started off with a -3/2. When you hear the word opposite, you're taking the sign and making it the new sign. You just do the opposite sign. So if it was a negative, it becomes a positive. If it was a positive, it becomes a negative. So opposite. And then inverse means I take whatever the original fraction is and I flip it over. So if it was 3 over 2, it's now 2 over 3. Same thing works if the slope's a whole number. If I have plus 3 as my slope, what's the opposite, first of all?
Negative.
Negative. And then I would flip it. So this is technically over 1, so it would be 1 over 3. Now, another way to check yourself is if you were to multiply these two equations, expressions, you'll get negative 1, always. Perpendicular slopes, if you multiply the slopes, you will always get a negative 1. That is a rule you can just write down and have memorized. So if I were to multiply this, I would get negative 6 over 6, which is just negative 1. Okay? All right. The other word you can use is negative reciprocals, if that helps you, instead of opposite inverse. This 3 over 2 becoming a 2 over 3, that's called a reciprocal. Opposite still works, negative to positive, positive to negative. Okay? All right, so example 2. We're going to determine which lines, if any, are parallel or perpendicular. So they're going to give you 3 lines. We have line A, which is y equals 5x minus 3. Line B, which is x plus 5y equals 2. And line C, which is negative 10y minus 2x equals 0. All right. First thing you need to do when comparing lines is put them all in the same format. Which format should we use?
Y equals mx.
Yes, y equals mx plus b, because this is the easiest and quickest way to find the slope. And when you're comparing lines, you need to know their slopes. So for b and c, we need to rearrange those, don't we? So b is x plus 5y equals 2. So I'm going to subtract the x. So I get 5y equals negative x plus 2. Divide by 5. So y equals negative 1/5 x plus 2/5, right? Okay, so I'm going to write that up here instead of what was originally there. So y equals negative 1/5 x plus 2/5. All right, so now let's look at C real quick. We have negative 10y minus 2x equals 0. So I'm going to add the 2x. I get negative 10y equals 2x. Divide by negative 10. So I get y equals, what's reduced to 10? I get what? Negative 1/5, right? Yep. Good. All right, so now I'm going to rewrite that up here in place of this line. So I have y equals negative 1/5 x, and there's no y-intercept. All right, I wonder if I can copy this. Let me try something. Oh, no. Wow. I can. Let's try this again. Try things. could have written it as fast as it took me to copy it, but you know. All right, so here's our 3 lines. They asked us which ones are parallel and which ones are perpendicular. So what do we need to look at when we're looking at these 3 lines?
Slope.
Just the slopes. So our first one has a positive 5, and then we have 2 that are negative 1/5. So which 2 lines are parallel? Yeah, so you would say B and C are parallel because they have the exact same slope. And then Geraldi, A is what? A is perpendicular to which ones? Perpendicular to which one? B and C. Yes, because you notice that 5 is the opposite inverse of negative 1/5. Very good. All right, any questions about that? So the nice thing is you just got to put it in slope-intercept form and you can solve it. Do you want me to do some more of parallel or perpendicular? Or do you feel like you got it?
Yeah.
Good? All 3 of you? I don't mind doing more. We can. Okay, because this way you get more time on your assignment. All right, lesson 4.5, numbers 4 through 26, but just the evens. Don't do the odds unless you're just wanting extra work.